In our previous lesson, we were looking at how to generally do the process of differentiation, how to find the derivative of a general and simple equation. Today I want to look at how to find the gradient of a curve at a particular point on the graph. For example, what is the gradient at this particular point that you've been given here? So in order to do that, we will need to perform a series of steps. So you remember that from our last lesson, we saw that the derivative of the gradient function tells us the gradient at the particular point where the coordinate, of course, is x. So now to find the gradient at that particular point, we simply need to substitute the given value of x into the derivative or the gradient function, and then we'll be able to find the gradient at that particular point. So we are going to have a worked example. The question may come and say, find the gradient of the curve y is equals to x cubed at the point 1, 1. So in order to do this, we must follow two simple steps. Firstly, multiply the original equation of the power of x and subtract 1 from the power of x like we did from the first lesson. So if our equation is y is equals to x cubed, alright, so what we simply need to do here is to just differentiate, then dy dx is equals to, we bring this 3 down, multiplied by x to the power 3 minus 1, giving us 3x squared. Alright, so our differential is 3x squared. Next, we're supposed to substitute now x is equals to 1 into the gradient function to find the numerical value of the gradient at the point where the x coordinate is 1. Why? Because we've been given that the equation y is equals to x cubed passes through the point 1, 1. So now, since this is the x coordinate and this is the y coordinate, when we've found our gradient function dy dx and we say that it's 3x squared, we now need to substitute this value of x into this gradient function, and then we'll get a numerical value with no unknowns, and that will be the gradient at that specific point. In this case, we're going to substitute 1, so it will be 3 bracket 1 squared, and this is the same as just saying 3. So dy dx will be equals to 3. Okay, that's very simple, right? So let's try another one. We already did this one where we calculated the gradient at the particular point, or which is 1, 1. Let's look at this one. Y is equals to x squared at the point 3, 9. Y is equals to x squared at the point 3, 9. So remember, the 3 is standing for x and the y is represented by 9. So firstly, to find the dy dx, this is our first step. We're going to bring this 2 down here, multiply by x and subtract 1 from the exponent or power or index. So it will be 2x to the power 1. Now we take the value of 3, substitute it into the gradient function, then it will be dy dx is equals to 2 bracket 3 to the power 1, and then our final answer will be 6. It's a very, very simple calculation. So the general tip which you need to take note of is that we will need to use only the x coordinate in finding the numerical value of the gradient function. In our next lesson, we will be looking at how to differentiate sums and differences of the form y is equals to ax squared plus bx plus c. If you've got any questions, if at any point you did not understand, feel free to rewind and play it slowly as many times as you want. You can also post comments and questions in the comment section, and you can reach out to us if you need extra help. Let's meet in the next lesson.